In lesson 1.5.1.6, we're going to look at a library of functions, which just means a set of functions that we should all know and be familiar with. We have already talked about graphing lines and piecewise functions, so we know about linear and piecewise functions. I know we know about these others, but we're going to refresh. We're going to look at the graph, the parent. We're going to call this the parent graph, which means it's a graph that hasn't been shifted left, right, up, or down, or stretched in any way, which we will do. But we're just looking at the basic graph, the parent graph, and we're also going to look at a basic table of values that goes with that graph. So quadratic functions. So the parent function would be y equals x squared. That is the most basic quadratic function that we have, so the parent function. And let's plug in some values. So every time you make a table, you want to think about what x's can you plug in. So what's the domain of that function? Well, there's no fraction, there's no radical, so the domain's negative infinity to infinity, which tells me I can plug in negatives, I can plug in 0, and I can plug in positives. So let's just take it easy on ourselves and just go from negative 2 to positive 2. So those are some easy numbers. So that's, and then we're going to plug those x's in. So negative 2 squared is positive 4, negative 1 squared is positive 1, 0 squared is 0, 1 squared is 1, 2 squared is 4. So that's the table I always want you to think about when you think of y equals x squared. Now if you plot this, you're just going to plot those points. So negative 2 up 4. Negative 1, positive 1, 0, 0, 1, 1, and 2, 4. And this is the graph that you should always think of when you think of y equals x squared. So this is the parent graph. And then you can change the squared in all kinds of different ways. But this is the most basic graph, table, and function. Now let's look at the square root function. So square root of x, which also can be written as x to the 1/2. Remember, a square root is just a rational exponent. So x to the 1/2 is the same thing as square root of x. So let's think about the domain of that. Well, here we have a square root, so you can't have any negatives inside. You can take the square root of 0, though. So that means our table can only start at 0. It can't have any negatives. And then we want to be careful for square roots of what we plug in if we want our table to be easy. Now, like I said, you can plug in any number from 0 to infinity. As long as it's positive, you can plug it in. But to be nice to yourself, plug in easy numbers. So plug in perfect squares that you actually can take a square root of without a calculator. So, for example, square root of 1 is 1, or square root of 0 is 0. So we know that. Square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. And that is enough points that we could plot the graph. So that is the table I would always think about for square roots. And then if we plot that, then we're going to have a point at 0, 0, a point at 1, 1, a point at 4, 2. So 1, 2, 3, 4, 2. And then 1, 2, 3, 4, 5, so a point at 9, 3. And then this is a rounded curve. It's like a sideways parabola. So it's as if you turn the parabola on its side. All right, cubic functions. So y equals x cubed. So with a 3 as the exponent. So that also has no fraction or no radical. So it's got domain negative infinity to infinity, which means you could plug in anything. So let's plug in positives and negatives again, just like the squared function. So I'm going to stick with my negative 2 to 2. And negative 2 cubed will be negative 8. Negative 1 cubed is negative 1. 0 cubed is 0, 1 cubed is 1, 2 cubed is positive 8. Plot those points. So negative 2 is down 8. Negative 1 is down 1, 0 is at 0, 1 is at 1, 2 is at 8. And connect those points with the curve. So this is a curve that goes up on one side but down on the other. So it's kind of like the one side of the parabola was flipped down. Now cubed root, so we're looking at y equals cubed root, and that you also may see written as x to the 1/3. So those are the same. You want to look at the domain of that. Now odd roots, for odd roots, you can take the cubed root of a negative. So that has a domain of negative infinity to infinity. So that means you can plug in negatives, zeros, and positives. So let's just, so we can plug in all of those, but we want, just like for the square root, we want to plug in things that we can easily get an answer to. So you want to think about your perfect cubes. I would start with 8. So let's go -8 is a perfect cube because because -2 cubed is that. So the cubed root of -8 is -2. The cubed root of -1 is -1. The cubed root of 0 is 0. The cubed root of 1 is 1. And the cubed root of +8 is 2. So those are the smallest that will give you whole number answers without a calculator. Now if we plot that, so then we're going to go -1, 2, 3, 4, 5, 6, 7, 8 is at -2. -1's at -1, 0's at 0, 1's at 1, and then +8 is at 2. So this one we have, it's just the cubed function turned on its side. So it should look like your cubic function. All right, moving on. Absolute values. We have talked about this already, but let's do it again. So the parent function would be y equals absolute value x. And we know that you can plug in. So this does have domain negative infinity to infinity because there's no square root and there's no fraction. There's no denominator. So you can plug in negatives and positives. So let's do the -2 to 2. So you can plug in negatives. We just know from absolute value we won't get an answer of a negative. But you can definitely plug in a negative. So when you take the absolute value of -2, you get +2. Absolute value of -1 is 1. Absolute value of 0 is 0. Absolute value of 1 is 1. And then 2 is 2. So that graph makes a V shape. So you're going to go left 2, up 2. Left 1, up 1, 0, 0. Right 1, up 1. Right 2, up 2. So this is the parent graph for absolute value, that V shape. Reciprocal functions, so that is y equals 1 over x is the parent function. And now we do have a denominator, so that means the domain is restricted whenever that denominator equals 0. So we have a restriction at 0, which means this has domain negative infinity to 0 and then 0 to infinity. So that means we can plug in negatives, we can plug in positives, but we cannot plug in 0. It's only restricted to 0. So let's plug in -2, -1, 0 is undefined. And then let's plug in +1 and +2. If I plug in -2, you're going to have -1/2 as the y value. If you plug in -1, you get -1. If you plug in 1, you get 1 divided by 1 is 1. And if you plug in 2, you have 1 divided by 2, which is 1/2. So when we graph this, -2 is at -1/2. -1 is at -1. 0 is undefined, and it's actually an asymptote. 1 is at 1. And 2 is at 1/2. Now those points are they don't really help you make a graph, but this is what the shape should look like. It is rounded because there are asymptotes there. and then it's rounded in quadrant 1 as well. So it rounds to the x-axis and it rounds to the y-axis.